Good morning, hackers. Welcome to, or whatever time it is. This is Saturday Hacker Day, and I am Taggart, as it says over there. You can follow me most places at MT Taggart. And what are we doing on this stream? We're doing security, we're doing programming, we're doing CTFs. Today, specifically, we are dedicating Saturdays to blue team work, defensive cybersecurity. So that's what we're going to be doing today. Pretty excited about what we have in store for you. So, but before we get going with our main activity, I had a couple of stories from this week in cyber news that I wanted to go over with you. Not too much, but enough that it warranted a message. Up first, we have an update from Microsoft regarding the SolarGate, SolarWinds, Sunburst, whatever you want to call it, compromise. It was kind of their final report of their slice of the compromise. And bottom line is there was some source code that was accessible by the attackers. So in particular, some Azure code, some Microsoft Exchange code, and also some credentials. But they stressed that there was not any live production credentials that were accessed. Things like API keys that are used internally, security tokens that are used internally. But again, Microsoft really stresses that they make sure that when that material is pushed to production, all of that is kind of cleaned up. So the likelihood that whatever the attackers were able to gather results in a 0 day or a compromise or something else like that down the line is pretty low. So good news for Microsoft on the SolarWinds compromise, and I hope that that's the last we have to hear about it. I'm really tired of talking about that story. All right, next story, a little bit closer to home for me personally, and one that I was really annoyed about when I heard about it. The Brave browser, which touts its security, its privacy bona fides, had a disclosure of a really serious flaw. It's not even really a vulnerability, it's just a flaw in it, in that one of the cool things about Brave is that with a very quick, Alt Shift N, you know, just like any other browser, you have private mode, incognito mode, Control Shift N, or Command Shift N will do that for you on a Mac. And you get an incognito mode that doesn't, save cookies, doesn't track your browsing history, things like that. But Alt Shift N actually opens up a Tor browser window, meaning that rather than routing your traffic through the regular internet, it's routed through the Onion router network, so that your traffic is completely anonymized. Sort of. The problem is that it turns out that in the Brave browser, that even if you're using the Tor window, yes, your HTTP traffic over that connection is anonymized, but the DNS requests when you're visiting Onion sites, right? So because in Tor, your domain names don't look like regular domain names; they're long hashes .onion or something like that. When you make those requests are actually still being sent to your ISP. So your ISP knows what Tor sites you've been visiting if you're using the Brave browser. So this is a massive breach of the agreement of privacy that Tor is supposed to have, and certainly the Brave has, with its users. Now, this has been a bug issue for a little bit, and it turns out that a patch is on the way. So that's good news. I'm glad that Brave has addressed the issue, although I'm really concerned that it was an issue in the first place. All right, I still recommend Brave though as the best browser around for my uses at least, and certainly when I'm doing security testing, it's the one that I go to. All right, so today, pretty cool bit of work that we have going on today. We're going to talk a little bit about something that's pretty real life, right? We're going to move away a little bit from the capture the flags, a little bit from the simulated challenges where we enter, answers, and we get a good feeling that we got the prize. This is a little bit closer to real life. What we're talking about today is vulnerability management. This is the process in which an organization has to disposition its assets as to what the security situation is, what the landscape is. And once you, so if vulnerability management starts with an asset inventory, we won't be going into that part of it today, just because I am a person and I don't have a whole lot of assets for us to inventory. But what we can do is take the next step, which is once you have an understanding of your assets, and you have established that you can gain access or visibility to them, you can use tools to automate the scanning of the potential vulnerabilities on those systems. And that's what we're going to be doing today. So we're going to be using a lot of really neat tools to do this. And full disclosure, some of these are going to be pretty new to me as well. And so we're going to be learning together as we go. So if I make some mistakes along the way, that's how that goes. That's what you get for streaming live and not doing recordings where you can cut out the issues. But I think that's valuable. I really do. So we're going to be using three things at least. We're going to be using OpenVAS, also known as Greenbone Vulnerability Management, which is an open source tool that you can use in Kali Linux. Yes, Kali Linux has blue team tools, sort of. I mean, the thing with vulnerability scanners is that they can be used both offensively and defensively. Probably why I like them. But so OpenVAS, we're going to use something pretty new called Nuclei, which is a Go language-based vulnerability scanner. I'm really excited to see how this one goes. And we're going to be using my old best friend Zap, the Z-Attack proxy, to disposition a web application. Have to thank you so much for the follow. Really appreciate it. Welcome. So what we're going to do to start is kind of walk through the setup here. One of the things that I know that some of you have been asking for is a little bit of a breakdown of setting up a home lab or setting up virtual machines to do some of this work. So I am doing that right now, and we're going to talk about how it goes. As a matter of fact, there's an issue with one of my VMs that I need to work through. It won't take long, but I think that's useful. So let's get started. Okay, get over to my live scene here. All right, so this is my Kali machine, and I'm installing the OpenVAS database right now, so we'll check back on this in a little bit. There's a lot of data that it needs to download, but before we start using OpenVAS or anything like that, let's talk a little bit about how we do a setup for a virtual lab. Now, I use Hyper-V because this is a Windows machine, and Hyper-V is just the most performant hypervisor available to me. But I'm a big proponent of open sources, as some of you know, and so I wouldn't necessarily recommend Hyper-V across the board, because there are things like VirtualBox, and that would be the other hypervisor that I would recommend. VirtualBox works on everything, or you could go next level if you want to set up a Linux-based hypervisor. You could go to KVM and just get that bare metal performance, which is really, really solid. But once you have your hypervisor of choice, we can talk about the concepts of virtualization in a little bit more broad terms, right? We don't need to talk about them with regard to a specific product. So you have your hypervisor, and then the next thing you want to think about is your networking. Depending on the kind of home lab that you want to set up, you want to set up different kinds of virtual networks. This is one of the reasons I really like Hyper-V. It makes the networking part of this a little bit easier to understand. You can do it just fine in VirtualBox. But so generally speaking, we have like 2 or 3 different kinds of networks that we can talk about. The first one is a NAT network, where we have an internal kind of ad hoc LAN that the hypervisor creates with a subnet that only exists in that space. And then the traffic is translated out to our outbound network interface. So those IP addresses don't exist on the rest of our LAN. We have a totally internal network that is isolated from that network interface, and you can set up DHCP servers on there if you want to assign dynamic IP addresses, or you can set everything to static so that those devices can talk to each other. And that isolated network, that's exactly what you'd want to have for a malware analysis lab or something like that, where you don't want that thing to send network traffic out. Um, and so if we look at our virtual switch manager here, you can see that there are a few of those. So this is my isolation lab. You can see it's a private virtual switch, right? And it's just a private network, nothing too interesting going on there. And then I also have this bridge network, and this is what I use for most of my labs unless I need isolation. The bridge network gives the device an IP address actually on my LAN. And what that does is allow easy communication back and forth. Now, a more mature lab would basically, I would take a second switch, maybe my isolation lab switch, right? I would set up DHCP, I'd set up a domain controller or something like that, and have everything connected inside of it so that I would have that isolation, but still have the ability to assign IP addresses. Essentially, the reason why I'm using the bridge network right now is because I'm not doing anything that is evil, one, and two, I didn't really feel like going through the trouble of setting up the DHCP server. That was it. Otherwise, we would be using a different kind of virtual switch. So once we have the networking set up, what do you do? Well, so I have, this is my Kali box, right? This is the one that I have actually in the background here running. So that's Kali. And then I have the Ubuntu lab machine. And the Ubuntu lab machine is right here. And it's just running in a window, nothing too particularly interesting. The way that I got it set up was I downloaded the Ubuntu image. I used 1804 in the hopes that we could get some, older vulnerabilities as a part of our report. But so I set up I downloaded the ISO, and then I went through the setup in Hyper-V, going to new virtual machine, and then kind of walking through the steps here to set up what you need, whether it is how much memory, how large your hard drive is, whatever, configure your networking, all of this stuff. I will also mention, pretty cool, Hyper-V has this thing called Quick Create, where it knows about certain kinds of virtual machines that you can kind of grab, right? So if you wanted to just really quickly set up an Ubuntu machine, you can just click on this, or a Windows 10 dev environment. Like, this freaking rules, because then I can just set up like a malware analysis machine like that, right? No problems. Really, really, really easy to do. And it saves me the trouble of having to go through like downloading the Windows eval copies, things like that. And we'll be playing more with this on the stream for sure. I have more RAM coming for the machine, so I'll be able to virtualize a little bit more without sacrificing some performance. But yeah, getting comfortable with virtualization, I think, is kind of a core competency for any kind of cybersecurity analysis. I really do. For a couple of reasons. One, because, if you want to set up a home lab and do your own experimentation, that's going to be really valuable. But also, this is maybe not the most popular opinion ever, but I don't actually think that cybersecurity professionals should start as security professionals, if that makes any sense. I really believe that spending some time in the operations side of things, learning how things are built and managed, really, really makes you a better security operator. So for that reason, I think getting your hands dirty with like, how do you set up a Windows or Linux VM, and how do you install applications on them, and how do you manage them? Like, understanding that life cycle is going to make you better at security, because you'll be able to understand what the life cycle of an asset actually is and where things can go wrong. So highly recommend, if you can, getting your hands dirty with it. And if, cost is an issue, which I totally understand. So, this machine is kind of like designed for this purpose. But if you don't want to, shell out for a virtualization capable desktop, that's totally understandable. What you can do is, set aside a little bit of cash for maybe doing some virtual machines in AWS or Azure, right? Spin them up when you need them, when you want to do the experimentation, bring them down when you're done. Your costs will be in the tens of dollars, right, rather than in the hundreds if you're careful, and that might be a better way of doing it. And we'll talk about how to do that in a future stream. Okay, so we have our Ubuntu VM here, and let me just quick show you. I've got IP-ADDR. I did install Docker on this. I don't want to use it for this thing I'm trying to do, but if I have to, I will. So we have an IP address of 192.168.1.103, and if I look over here, I have an IP address of 192.168.1.109. And sure enough, if I ping 103, I can talk to it. As a matter of fact, I can even SSH into it, I think. If I SSH server admin at 192.168.1.103, I should be able to hit it. Yes, I will accept the fingerprint and enter my super secure password. And now I'm logged into my lab machine. So you can see that the two virtual machines can talk to each other. And that's going to be important for our vulnerability scanning. So that's part one. Now, part two is I want to set up an application on this thing for us to actually work with. So what application do I want to set up? I want to set up DVWA, or Damn Vulnerable Web Application, which we've played with before. And why I love it for this particular exercise is that it's a PHP application that has a database requirement, right? And a whole bunch of problems. So bad configuration of the database will be something that our scanner should be able to see, as well as the web vulnerabilities. Let's get some music going, just a little bit. Yeah, just a little bit of tunes. Not too much. All right. Now, the problem I have is that I need to finish setting up DVWA. And so we'll walk through what that actually entails. The web application, let me get back to that terminal. You know what? This is going to be easier to do just from the SSH in Kali. So let me close this window. I don't need it if I'm SSH'd in here. Okay, so I'm connected there, and if I ls, you can see I've got the DVWA window. Let me do the usual thing where I swap out the... There we go. Or not swap out, I want to make sure that the window doesn't go below my head. All right, come back up here. Now, cd dvwa. I can type. Now, I've already set up MySQL on this machine. And just to show you, I can do MySQL-u root with -p. And then if I enter the root password, okay, so MySQL is set up, right? That's all good. And as a matter of fact, if I go to 103, you can see that I have the default Apache page. So the web server on this thing is set up as well. And that was just a matter of running sudo apt install Apache 2. So, you know, pretty standard web setup. Now what I want to do is, if I look in my DVWA folder, and this was just pulled from GitHub, you can see there's this config directory. And I want to go in there because there's this config.inc.php.dist, and now there's this config.inc.php. Now I want to modify this so that it is commensurate with my actual configuration on the machine. And you can actually see in the install instructions here that it tells us that, right? That we're going to want to make config.inc.php, but we want to set up this stuff. Okay. Now, the next piece that I'm going to do is wrong. Okay, it's insecure. And that's by design. We want to see what gets caught with our scanners. But we're going to vim this config.inc.php, and we're going to modify it. Okay, so the DB server is localhost, that's fine. The DB database is DVWA, that's fine too. The DB user is actually root. We're going to do this wrong. right? Because we made the root user, but we didn't make any others. And horrible, horrible password, right? And this is one of the problems that I have with like PHP applications in general, is that you always end up with a config file in your web root that has credentials in it, right? And password reuse is a real problem. So very often this can be a privilege escalation vector right here. Okay, so we have this thing. So we have DVWA, right? But that's not actually, it's in our home folder, right? It's in home server admin. That's not really where I want it to be. I want it to be in the web root. And in our case, that is var www HTML. So I want to sudo cp-r for recursive the DVWA folder into var www HTML. But that's not all, because if I do that just like that, I do have a problem. This is more ops than security, but good to know. If I do it just like that, www HTML, you're gonna see that, oh, it is root. That's weird. I suppose that's fair enough. But what I actually want to do, this shouldn't be root. This should be the web user, which is www data. So what I want to do is sudo chown -r www data, too many W's, data, the owner and group are the same, var www HTML DVWA. Okay, now if I visit DVWA, currently unable to handle this request. This is the problem I was having. Restart, patch 2. There we go. Nice. Pretty exciting. Okay, so this is where we set up DVWA. Right, this is all evil. And we're going to hit create reset database, which is unable to connect to database. Database has been created. Setup successful. Please log in. Awesome. Okay. So, DVWA is terrible, right? By design, right? Our login is admin and password. And I'm also going to set up the DVWA security to be low, specifically to see what gets caught in it. All right, this is exciting. So we have our virtual machine, we have our web application up and running. Now we got to scan this thing. So how do we do that? The first tool that we're going to use is Greenbone or OpenVAS. And so I have this thing set up on Kali, and you can kind of actually see where it is here. Let me get the password for this. So I think it's running. Let's confirm. Sudo GVM start, which is the Greenbone vulnerability manager. Okay, so now it gives us a web UI link at 127.0.0.1 port 9392. Oh, and it opens it for us. How handy. I wonder what it will open in. So nothing is the answer, but that's okay, because what we can do... It is HTTPS. Let me just accept the cert. Okay, so now we're in the Greenbone Security Assistant. Let's go to admin and enter this password. that they gave us in the startup. Pretty rad. And then I'm gonna group my settings just real quick. I don't want to clone the user. I want to okay, I guess I'm gonna just save that password somewhere because yeah. Not the most secure thing, but you know, it's my Kali box. Okay, so Greenbone Security Assistant. What are we dealing with here? We have to set up scans, right, and assets in order for us to deal with them. So, and this is also meant to be our dashboard where we manage our vulnerabilities. So we'll start here with our assets. We'll go to hosts. Right, as you can see, we don't have any, but we can click on new host. And we'll give it the IP address of 192.168.1.103. And our comment will be Labuntu. That's the host name. Hit save. All right. Configuration. So if we think about what we're trying to do, this is not just an HTTP or like external scan. What we want to be able to do is actually remote into the machine, right, and get operating system level vulnerabilities. In order to do that, we have to set up credentials. So here is our credential set. We don't have anything set up yet, so we can't authenticate anywhere. Let's add some credentials. So we're going to add, we'll call it server admin. And generally speaking, in an environment, what you would have is like a service account or something with limited permissions that you can use to set up these scans. Okay, so it is username and password. And we know what it is, right? It's server admin, and then all right. So now we have our credentials. Let's go to targets. No targets available. Let's give it a target. So we can give it hosts, manual or from a file. And we can also see that we can set up credentials here. So this is where we can actually set up our scan. Okay. We're gonna scan the, excuse me, the regular ports, right? We can either do top 100 or all. And in this case, we'll just, for speed, we'll do the top 100. Right? We can also add additional configurations if we want to. Like, I think Nmap has a top 1000 that it does, which is pretty handy. And, okay, so let's see, anything else? Reverse lookup, we don't care about that. Okay, save. Whoa. Oh, I forgot to add the host. I still have a number pad on my keyboard, and I don't really understand how anybody lives without it. I know that's an unpopular opinion. Everyone wants the 10 keyless keyboards. But I love my big keyboard with the number pad and the insert, home, delete, and page up, page down keys. I really don't know what I do without them. All right. We have ourselves a target. I love that the clone target icon is a sheep. Okay, so we have our target. Now we actually have to set up a scan. Set up a task, right? And this is where we set up our scan tasks. New task. And so you can set up your scan names however you want. Time stamping them is always a good idea. So 2021, 02, 20. Ubuntu flat. Fixing new Ubuntu server. Right, so you can see scan targets. Now we have a target. No alerts necessary. We don't have to schedule it, right? Add results to assets. Yeah. We'll see if we have to deduplicate that. Scanner. OpenVAS default. That's fine. Notice there was also a CVE scanner that we could use as well. Okay, I think this looks pretty good. And then to fire off the scan, we would hit start. Let's see what happens. All right, so it's requested, and then I don't know how long it'll take before it kicks off. It should kick off pretty much immediately. Yeah, it's queued, and then it'll go to actually running. So we'll check back on this in a minute, and while we're waiting, let's also check out our other tool that we're going to play with today. Oh, here it goes. The other tool we're going to play with today, which is definitely something that is new to me, is Nuclei. This is really, really cool. So Nuclei is a fully open source vulnerability scanner written in the Go programming language. And it is based on publicly available templates. So you write the template in YAML, and then, off it goes. Now this, I can't tell. I don't know that it's just for HTTP, but it may be. And if so, then we'll, run it against our web side of it. I was under the impression that Nuclei was for the whole Smash. It wasn't just for... yeah, so it has TCP as well. So it is more than just that. So we have Nuclei installed. I have already run this command. I have the Go language, platform installed on Kali, and I've already run this command. So if I go into my command line here, you can see I can run, actually cd Nuclei. Yeah. You can see I have Nuclei. Oh, I don't have it as part of my path because I forgot to do something. Let's fix my path so I have Nuclei as part of it. So this is just going to be /go/bin, I'm pretty sure. And exec fish to get my new shell. And now, yep, Nuclei is there. So you see, I have Nuclei-h, and that can give me the help I need for the command. So obviously I love this because it's a command line tool and I prefer them. But it also has just a lot of really neat options. Now, one of the commands that's really important is update templates. And so if we do, we'll try that update templates. It's checking our Nuclei templates. Now let's go look at some of these things. So we'll go to cd Nuclei templates, and let's go to CVEs, for example. This might be fun. Let's go to the 2021s. Something new. $22,873. Why does that ring a bell? Let's look at this YAML file. Okay, it's not what I thought it was. But so check out the way this is built. So you have the ID, you have the info, and then the requests. So you have a method of get, and then you set the base URL, whatever it is, right? And that's taken from our target URL's text file when you run nuclei. And then it's looking, this is the test right here, right? So if all of these match, because it's an AND operator, then the test is validated. That's pretty cool. Let's take a look at another one. Look at misconfiguration. That might be fun. These all look like web things, which is fine. It's all WordPress, Moodle. Okay, so it may actually be just a web scanner. Okay. Still, we're gonna still fire it at our thing, right, to see what happens. That should be fun. So the thing that we need to do for nuclei, if I recall, is we either give it everything, or we just run it with the target URLs, right? So I have to give it the target URLs.txt or whatever. So I'm going to echo 192.168.1.103 to our target URLs.txt. It doesn't have to be that file name, but we'll just keep it that way for clarity. Okay. I just realized that my text is a little small, so I zoomed it in for y'all. Alright. So let's pause on nuclei. Let's go check on Greenbone, see how it's doing. Almost done. Oh, crap. Okay, we're fine. Everything's fine here. Now, it seems like something might have gone amiss. I'm going to wait until the scan is actually done, but, you know. You would expect to see other ports open, right? So we'll see what happens when the scan actually finishes. Meanwhile, why don't we run nuclei? Why not, right? Unless we brought this thing down somehow. Let's just check to see if 192.168.1.103 is still up. Yep, still up. So we didn't overload it. So that is something with vulnerability scanners you do want to be careful with. It is possible to really like knock over a sensitive machine if you're not careful. So generally what you want to do is tune your scanner to your environment. I know that, you know, in my workplace, we have some sensitive devices, and so we make sure, and there are certain TCP ports that we have to avoid because we don't want to knock it over. So we're just going to give it this L, and yeah, let's run it. Nuclei -L. That's a good question. The expected Greenbone output should be just like Nmap's output? Not quite, because it has better data than Nmap's, right? It has a whole database backing it up of CVEs and tests for those vulnerabilities. So you should see a whole bunch more than you would with even an Nmap-A running all scripts test. Assuming it works. I wonder if this thing's actually going to stop. Alright, let's fire off Nuclei and see what happens. What? Oh, okay, fine. We have to give it templates. Let's say CVEs just like that. Can we do that? Yeah, we can. But yeah, in theory it is. So it's not just doing the web side, right? We gave the thing credentials so that it could SSH into, sorry, wrong window, that it could SSH directly into the machine and do a scan. You know what I just realized? We might not have done the right scan config. Let's look at our base. Let's make a new scan config, actually. Base with a minimum. Alright, can I edit this thing? Yes. Dope. Okay, so this is where we actually get to set this thing up the way we would expect. So what are we gonna do? We're not doing Amazon Linux. We're not doing AIX. CentOS, no. Citrix, no. Compliance. Databases, yes. Debian, yes, because it's Ubuntu. We're going to do that one. Default accounts. FTP, just in case. General, yes. Gain a shell remotely. Yeah, why not? We can do here's the Nmap NSE stuff, right? We want to do that. Port scanners, service detection, obviously. Let's see what happens when we click on the edit button for one of these, right? If I click on actions. Oh, so that takes us into the actual scans that we want to do, right? Now, I am curious about the trend button. I'm not as familiar with that, so let's look that up, right? Actually, Greenbone. What's that about? Always helps to read the documentation. So here you can see that we can actually do a test. We can specify the tests that we're doing for each category, right? But I'm going to do all of them, right? And surface detection. Here we go. Ubuntu local security checks. Yes, please. Web servers. Yes, please. Web application abuses. Yes, please. Okay, now let's see what happens when we save this thing. Meanwhile, over in Nuclei, yeah, so update directory. Weird. Let me move the templates back to where they were originally. Yeah. Let's try this again. There we go. No results found. Those are the CVEs. Let's try something else. If we run it against everything, do we have to give it a... Yeah, we have to give it templates. So... let's actually... let's run Nuclei from that folder. And we'll give it... let's see. Technologies. Right, vulnerabilities. Just all vulnerabilities, right? And then T. Wow, it really doesn't know what to do with I think Nuclei needs to do some work. Maybe I can open a pull request to help fix this, because it seems like it doesn't know how to do pathing correctly. What? Oh, no, I'm just being stupid. It's the -L, not the -T. There we go. Now, again, it's interesting in that it's not giving us any vulnerabilities, but I wonder if we give it the DBWA, if we get any different results. No. Let's see. Let's try default logins. Because that should work. Right? Because we know. Interesting. Well, maybe we can try writing our own custom rules, right? To see if we can test it. That might be fun. Let's check back on Greenbone. Okay. Our Linux system scan has right. Let's go back. Oh, yeah, we got severities, or we got vulnerabilities. Check that out. No, just kidding. No, we didn't. Let's take a look at this. So it was the full and fast. It took 12 minutes, but let's see. I mean, I know it's not that well secured. Let's look at the report. There's one severity? I don't believe you. TCP timestamps. So obviously it was able to connect because it's seeing Apache, it's seeing gzip, it's seeing applications. Interesting. This thing's fairly well secured, but it's not, because we know it has other problems. I want to run my own custom template against this too. Let's run that. So we're going to run a new task. And then we're going to use the scan config of Linux system scan, right? 21 0220 build to lab 2. Keep it the same SAN target. Add results to assets. Sure. And this looks good. The target is where we defined our credentials, right? So we're good there. And okay. Go. All right, let's see. Let's see if we can use Nuclei to create a template that actually makes sense here. Oh, also I wanted to check assets. Yeah. Now it should have populated the hostname here. But at least it's getting the OS right. All right, let's go into default logins, right? And let's make a dir for dbwa. Or actually, let's like make a PHP, and then let's see. Let's see if we can copy the SolarWinds to the PHP and call it dbwa default admin.yaml. Let's see if we can get this going. All right, so cd PHP. Let's vim this up, dbwa default admin. Okay. So we're gonna change up a bunch of this stuff, right? Now I'm the author. PHP, dlogin, we'll give it dbwa. Okay. Okay, request get. Now this is not going to work. We have to change up all of this. So how do we log into dbwa, right? Let's log out and actually see how it goes. And well, we're going to be using Zap anyway, so no time like the present. Let me fire up my pen test profile here. Someday I'll learn how to type. All right, and let me get Zap going. Yeah, you know, it's occurred to me. We've used Zap a million times on this stream, but we've never actually done a report from Zap. So we'll do that. Oh my god, have I not enabled dark mode for Zap? Yes! Okay, well that's happening right now. Pandemic Avocado, dope name, and thank you for the follow. Ugh. There was other stuff that happened in Zap 2.10 that was important, but also there was dark mode. Much better. Okay. So what we're trying to do, we're trying to build a custom nuclei template to test dbwa. And to do that, we're first going to get the information about how this thing actually processes logins, to do that, we're going to route our login through Zap. So we've got our information coming in to Zap, all good. And then I'm just going to log in with admin and password. And let's see what that request looked like. Here's our post. Let's look at the request. So username equals admin, password equals password, login, user token. The user token we don't care about so much, but we do care about admin and password. So let's take a look at these. I know that the request method is going to have to be post, and the path is going to be base URL. We're going to get rid of all of this. And actually, we only need the one. So let's try / what is it, login.php, right? No headers. But now I have to look up how to define the post body, and we're going to do that in the nuclei documentation. One hopes, templating guide. Oh, neat. Specifies a body to be sent along with the request. For instance, body some random JSON. Or body's a string. So, oh, that's handy as hell. So if we give it JSON, it'll sort it out as JSON. If we don't, then it'll be www URL form encoded or whatever that is, which I believe we're not sending JSON in this case, so we're going to do it this way. So it should be just copy pasta from Zap. So also, I think we have to follow redirects. I saw that someplace else. Let me get rid of all this. So our matchers, what do we match when we log in, right? Welcome, I think, is all we'll need. Yeah. I think this is it. So this is exciting. I think this is fun. You know, you may not, that's fine, but the ability to customize your tests like this in such an easy way, really interesting. Now nuclei is very new. But it's new, and so, you know, there's probably a lot of work left to be done in terms of creating these kinds of these templates for scanning. A lot of work probably in things like WordPress, Joomla, right? That could really help people out. So if you were looking for a place to do some contribution to an open source project, this might be a really solid candidate. And the part, I believe, is the body. And we can check that out, right? Matchers, matched parts, body, header, all. Yeah. So it's the body of the response. Cool. This is really cool. Okay, we'll get rid of this other matcher. We will leave the type of status 200. That should be there. And I'm trying to think. Do we need anything else here? No, right? Set the body. Yeah, I think we're good. Oh, wait, no. I wanted to see if we have to follow redirects. That was the other thing, yeah. And that's part of the request. So I'll just put that down at the bottom. Okay, so with that done, this might be this should be cool. So yeah. So here we're going to do default login / dvwa. No, php / oh yeah, we can just leave it like that. And then see if this works. No results found. Interesting. But it did take our template. Look at that. Now, I wonder if that's because we needed that login token. Let's see what happens in Zap if we try to log in without it. We get a 200, but we don't get... Okay, so we do need the CSRF token. Now, I wonder... Okay, so there's a way to pull the CSRF token. Extraction split. While writing a template for chain request requires dynamic value to use at runtime. For example, a CSRF token. Headers or any value. So example of part body, internal true. Okay. Let's try it with the hard-coded CSRF token, and then we'll see if we can write the extractor. No results found. But it's possible. Now, hang on a second. Can I get more? Is there a verbose mode? Yes. Great. Because I want to see what's actually happening. Oh. This may be the problem. I'm sending it to the wrong URL. Yes. This is actually being streamed to YouTube as we speak, and it will be there available for review. Yeah. No, I know that this stuff is pretty dense, and it's good stuff, but doing it live isn't always the right time for everybody or whatever. So yeah, I always make sure that I cross stream it to YouTube. In this one particular instance, crossing the streams is good. How's this scan going? Ugh. Yikes. Same results. Wild. Well, maybe this is what we get for having a pretty reasonably configured machine. But this is actually also a really good point in that, you know, we have a vulnerability scanner. Let's actually take a look at the report. By the way, this should go without saying, but only ever scan stuff that you have permission to scan. Otherwise, you're doing crimes. Don't do crimes. Even though this is theoretically a defensive tool, it doesn't have to be. It can be used to enumerate vulnerabilities on an attack target. And if you are attempting to gain access to a system that you don't have permission to gain access to in the United States, you are violating the Computer Fraud and Abuse Act. Don't do that. All right, so it really seems like it's getting the right stuff, right? It's finding Perl, it's finding Apache, it's finding Python, it's finding all the right stuff, but it doesn't have any like serious vulnerabilities. I guess that's what I get for, you know, a pretty new configured machine. That being said, there are like known misconfigurations on this, and how do you find it? Well, we're still working on Nuclei, but like, what does Zap tell us about this thing? Let's talk about Zap for a minute. So we have this thing set up in DVWA, right? And it is a PHP application, which means that Zap can do some pretty cool stuff with it without too much extra effort. One of the things that it can do is spider the thing. Now, most of the training that you see out there, and most of the, you know, like the offensive guys, like Heath Adams, the Cybermender, or Ben Sigedipor, Nahamsek, like a Stoke, all those guys, like they use Burp Suite. Why do they use Burp Suite? Well, because it's really good. But it also costs $400 for a license for a year, and despite the fact that there are some add-ons you can get for Burp that are really, really effective, I have built my workflow around Zap, and so far, for the work that I'm doing, I have not found it wanting. So I'm spending not $400 a year, and so when I present this information, I'm going to present it to you with tools that don't cost, right? So that you can get started learning this stuff as well without that overhead, that financial overhead. So, just FYI, like everything we're doing, obviously you could do in Burp Suite, and if you want to do it in Burp, that's totally fine. But I'm going to keep working in Zap because I like it. Okay, so we have the site. I'm going to include it in a context, which just means that I'm targeting it, right? This is my scope. Okay. And there are a few things that I can do from here, right? Like I can do a basic spider. Now I'm not going to find much because I can't log in just yet. I haven't set up any credentials. Nevertheless, if I start the scan, I should be able to discover some things. And sure enough, you'll see extra data come in here, right? Like the icons folder. I'm getting some information. And this is just from the Zap scanner trying to spider through all the links that it detects in the pages. No robots.txt. what you are seeing here, we've got JavaScript stuff as well. And then if we wanted to do a little bit of testing here, we could do it. So if we wanted to do like testing for default logins, we don't have to, we could set up Hydra and do all that cool, you know, hacker shit, but we don't have to. We can actually set up a little bit easier of a fuzzer in Zap. So here's how that works. So if we do login.php, and this is what we want to do, we can set up some fuzzers. So to do that, I can right click or double click on the thing I want to fuzz and choose fuzz. And so that'll be my first my first fuzzer. And we choose payloads, add, and then file fuzzers is what I want here. Now, oh, sorry, actually, does authentication have it? Yeah, it does. So I have usernames, right? But I also can do, instead of file fuzzers, I can add a file. And I can go like, I think I have sec lists on here, right? Do I not? User. Oh, user, share. I should have sec lists in here. Yep, there it is. And then I'll do like usernames, top username short list, right? No problems at all. Then hit add. So that's what that's my payload for the admin section. And then if I do a password here, I want to add a payload in that section. Add, and notice that I just highlighted that part of the request. File, and then let's go find passwords. I think there is like a common passwords. Yeah, let's do like the dark web top 100, right? Not even that hard. And look, you can see passwords right here, so we're going to catch it. So let's hit add. Okay. And let's see what happens. Now, we also want to see, we know that we're looking for welcome, right? So we're actually kind of doing the same scan we were doing with Nuclei, but we can do it in Zap. So if we do a message processor, we can add a message processor and call it a tag creator. This is kind of cool. So this is where we can use the Zap's response to match a regular expression. So we're going to match. We know that if we have a successful login, we'll see welcome. And we can tag it with welcome or success or you know, whatever. And we'll see that tag come in as we do the fuzzer down in the results window. All right. And with that, we're going to start the fuzzer. It's in light mode because I guess Zap didn't render that correctly, but that's fine because we didn't restart Zap after we applied the new theme. It didn't take that long to run, you know, 1,683 combinations. And did we get any tags? We did not, possibly because the CSRF token changed. Because admin this should have done the job. The response was 0 bytes. Oh, crap. What did we forget to do? Follow redirects? Yes, we did. So we'll have to reset up that fuzz. Now, one thing that does drive me crazy about Zap, I don't love this, is that I can't duplicate the fuzz. Like, I don't think I have a way of copying the configuration from one fuzz to another. Right? I have to basically rebuild the whole thing. And that I don't love. Follow redirects is what we were supposed to catch or check before in order to make this happen. So let's set up the payloads correctly this time. So file, user, share, sec lists, usernames, top username shortlist. Very good. And for password, add there, add a payload, the file, go to passwords, and top 100. Okay. We are following redirects, that's good. And we're gonna add that tag processor, right? So if we seed the word welcome, we'll call it a success. And off we go. Okay. A lot of reflecteds. For whatever reason, this was a big response, and I don't know why. Oh, whoa. CSRF token is incorrect. So that's part of our problem, is that we're not dynamically updating the CSRF token. So one thing we can do to fix that, right, is to reload it. But I'm actually going to look, because I don't know off the top of my head if that has a way of extracting tokens. Well, I'm not going to a Google group for this. Oh. God. There's a thing in Zap I just learned about called the anti-CSRF token refresher that will automatically regenerate the token for you. Okay. And this is, by the way, this is from Simon. He's the guy who wrote it, so wrote Zap, so we can probably trust what he's saying. Let's try this one more time. So we'll fuzz this. Now, add the, so it's a message processor. Okay, so I don't want a tag creator. Is it a plugin? Let's find out. No. Hmm. Perfect. So this would be a script to grab it. I don't want to do that. I want to see if I can. See if there's another way to do this. Do new fuzz. So we'd have to write a script to pull it. I hate that. Well, it's doable though. All right. Let's go back to, we've got a bunch of different plates spinning here. Let's go back to, we don't need to do green bone anymore. We kind of sorted that out. Although I did want to see if we could make a nice report from it. Because the thing with vulnerability information is that you have to give it to somebody, right? Generally speaking, the security team is not the team responsible for patching. What that means is you have to present your information to somebody else in order to make it useful. So we do have, these charts here, but this doesn't give us as much information as we might necessarily want. So let's see, report formats. Anonymous XML, here's PDF. So if we go to scans and reports, I don't want a delta comparison, I just want the report. I don't want trigger alert, I don't want to. Just want to export the, if I hit download, what do I get? Okay, here we go. So let's see what the PDF report looks like. Because again, generally speaking, you're going to be sending your data to people who are less technical. Or, that's not always true. Technical in a different way, right? They don't care about the vulnerability details, right? They care about how to patch it. And so you want to make sure that the data that you're giving them is that, right? Not, like how to exploit it. You gotta, think about your audience. Okay, let's download this report and take a look at it. There's not going to be a lot there. Every time I see that font, it's like, okay, LaTeX, how you doing? Okay, so it did. This is nice. We see that we had a successful authentication, right? So, and then look at this. It gives you the solution, right? How to disable TCP timestamps. I don't know why that's the only thing it found. But, yeah, that's what the report looks like. Now, let me go to our scan config again, because we really should have seen... Let's edit our Linux system scan. Oh, the scan config is currently used by one or more tasks, therefore only name and comment can be modified. Interesting. So let me trash these tasks. So tasks are meant to be repeatable. I want to see if I can get at least like database information, you know? And then the next thing we'll do, databases. Yeah, okay, so the MySQL stuff is set. Default accounts is set. I wonder what that looks like. Let's look at default accounts. That's interesting. We'll run port scanners, we'll run privilege escalation. What are the settings? Okay, we're doing Ubuntu local security checks, we're doing web application abuses, we're doing web servers. Okay, that doesn't matter so much. SSH authorization, we already sort of set that up in the configuration. Okay. I'm try more of these. Well, let's use the task wizard this time. No! Dang it. Yeah, that's no good. Let's set up a new task and do it the right way. Ah, see? So it creates a different target. That's interesting. Let's drop our minimum QOD to 50, just in case that does something. Alterable task, yes. And we're going to do the Linux system scan. Okay, set that up and take that off. Let's go back to another plate that we have spinning, which is the nuclei templating guide. So same problem, right? If we want to scan DVWA, how do we scan it? We need that CSRF token, so we can set up an extractor. This is cool. So this is actually how we want to do it. I like this. So we're going to add an extractor. Does it matter where? Let's add it just at the bottom here. And type regex. Name. Yeah, it's going to be part body. And we'll do the regex here. And so, okay, so whatever we put in the capture group, that's going to be our token. Neat. So then let's go look at our login page and see what we actually have here. Oh, actually, we don't even need to do it. We can get it from from Zap, right? Yeah. Okay. Let's see how that looks in the templating guide. Okay. Looks like we might need to do \s for the spaces. That's fine. And then right in here, how long is that? We'll use the alphanumeric, but wait, it is double bracketed. Interesting. And it's how long? So how long was ours? So over here, we will set up the 32 count there. Now, once we have the extractor configured, how do we use it then? And internal is true. I don't need it to print it out to the terminal. So put that down. And then I think I want to move the extractor section up above here because now how do we use Did we use an extractor name which can be reused in any part of the request dynamically? This feature supports the raw request. Well, I don't want to do that. Let's go back to extractors. A list to extract. No. So it says here we use extractor name as variable API key, which holds the value and can be reused in any part of the request dynamically. This feature is supported in raw request format only. That kind of sucks. Let me try it without it, just in case. That might be it seems like a weird limitation. But I think I understand what's going on here. So here, I should be able to insert like CSRF token. And the double brackets should, just like we do with the base URL up here, should mean I have access to that that formatting. This is yeah, this is very Go in its structure. Missed a space. Uh-oh. Found a unknown escape character. Let's put the spaces back in, see if that works. No, could not parse file. Unmarshal errors. Cannot unmarshal string input into string. Interesting. Okay, so it needs... the escaped spaces. Am I missing any? I don't think so. Did I get something else wrong? Entirely possible. No, that looks correct. And they are single quotes, annoyingly. Found unknown escape character. But I'm doing this exactly the way that they say, right? \S? Yeah. I wonder if it's the single quotes. But probably not, right? Because no, that wasn't it. Let me try this with single quotes outside and double quotes inside. I know that that's not what it actually is, but I think that might be the issue. Ugh. I don't need your quote auto-completion right now, Ben. Now it says, cannot unmarshal string input into string. Oh, wait a minute. It's YAML. YAML is the problem. Because if you look carefully, the regex is part of an array. Hey, that one worked, but it didn't find anything. I'm gonna pull internal true out of there so that we can actually see this thing printed out and see how it's working. It's not capturing that at all. Can I take does it take more than one V for extra verbosity? No. Okay, well now that we have this figured out, let's go back to what it actually is, right? Which is quotes here and single quotes in here. And hope that it can figure itself out now. Okay, we're back to found unknown escape character. Maybe it really... Maybe I forgot to escape one of these before. Mm-mm. Does it have to be single quotes? Ooh. Now this is different. Line 17 did not find expected dash indicator. What if I just leave the single quotes as is? This shouldn't work, but we'll try it anyway. Yeah, that's not working out the way that we wanted it to. Why do we have to give it the whole thing? I guess that doesn't really matter. So we had it working. Okay, so things we know. It's got to be single quotes on the outside. And if we try to escape all the single quotes, it doesn't seem to work. Right? Like it stops parsing. And if we put the double quotes on the inside, it works fine. The problem is that that's not actually what it is. Right, let's see. So if I run this again. Yeah, it doesn't parse. Now, it'll run, but fail, right? Okay, so Nuclei has some work to do. Let's see if we can capture the Sea Surf token using Zap. Also, let's go take a look at our Greenbone. I'm gonna have to re-log in here. Oh, I didn't even kick off this scan. off it goes. Now, so for Zap, what it's saying is we would need to basically write a script, and that's fine. That's kind of what Zap's whole thing is, right? You can customize what we're doing. So we're going to try to get No, I don't love this. Because what we want to do is we want to... Let's go into Zap and see what we have. So let's go to the script window. And fuzzer HTTP processor. So we're going to call it CSRF token extractor. Yep. And we're going to use Python. We don't have any... Hold on a second. Do I not have the community scripts installed? No wonder I'm having so much trouble here. Wait. So I do have the community scripts. Do I... Let's see, passive rules. Yeah, there's the hunt stuff, so I do have the community rules. Okay. So... No templates for this, unfortunately. Okay, let's take a look at the... So let's see. Process result, process message. Yeah, there's some learning I need to do here. I'm really annoyed that I can't just fuzz this thing correctly. Now I will say that although this thing is being a major pain in the ass, I can use some of my evil tools and get it to work the way that I want. So I can use like Hydra or FFUF. I don't even have FFU installed, but with Hydra, I do think I can give it a proxy. No? I know I can give FFUF a proxy, so let's get that going. So with FFUF, pretty interesting how this works. So fuzz faster, you fool. We give it data, and it's kind of the way that the things that we can use to fuzz. So, for example, there's our proxy URL. So, for example, we could do FFUF x post. Let me actually get the man page up here so we can have it, right? And we're going to follow the redirects. We're going to give it the U of http://192.168.1.103 /dbwa/login.php. The data that we have to give it is very similar to, well, it's identical to what we were looking at here. So let's take a look at the request, right? We'll give it this. And we have to modify this a little bit because we're going to say username equals admin. For now, we'll say password equals fuzz. And the reason we do that is because that's how the fuzzer works. It replaces fuzz with whatever we want. Now, we're going to give it So we're going to give it the -w for the word list, right? And the word list here is going to be user, share, sec lists, passwords, and we're going to do dark web top 100.txt, right? I think that's pretty much. Oh, and we have to give it the proxy, of course. And the proxy is going to be http://localhost port 8000, and that will pipe the FFUF traffic through our ZAP proxy. Or not. Is it on 8080? Where's our local proxy? Yeah, it's 8080, not 8000. My mistake. Let's try 8080. Hey, there we go. Now that gave us a bunch of stuff, right? And you can see the results here. Now they were all the same size, unfortunately, which means that we still have that CSRF token problem. Now let's see if FFUF has a method for dealing with CSRF tokens. No. Well, then we'll do one more thing, which is, of course, just to kind of cheat. And let's get the request here. User token. So we can modify this with the current CSRF token. And we can also, this is kind of neat, we can filter the size. Now that we've seen what the default size is of 1415, we'll knock that off so that we won't see the failures. Okay, looks like we didn't do any better that time. Yeah, unfortunately, it's gonna hit us every time. Now, can we use Hydra with a proxy? That's interesting. Oh, it's an environment variable. Interesting. Okay, well then we can do it. So with Hydra, what we would do... No, we still have the same problem. So maybe this is something we'll do next time, is like how to dynamically update CSRF tokens. Once I do some more research on it. That should be fun. But for now, let's actually use Zap finally to the right way. So let's give it a real set of authentication tools, right? So we're going to do form-based authentication. That was fast. Let me do that again. So here, we're going to set up our context. We do form-based authentication. And then we're going to go and use our post, right here. Username, set up the username, set up the password. And then over in users, we add a new user, call it admin, and we know that the password is admin password. Okay, fire that off. Then, even with that, a spider will give us a whole bunch more information now that we have that set up. And then let's attack the thing. Let's see if we get any information. Now I'm still seeing some fails here that I wouldn't expect, right? I'm seeing that it's not finding everything that it should find. So I'm stopping the scan, and this is where, you know, the browser comes real handy. So if I come into admin password, right? So index.php, I should be seeing that straight away. But then I should also be able to see instructions, right? I should be able to see all of these. I'm annoyed that I wasn't able to. But now that I'm logged in, let's see what happens if I'm actually able to spider this thing. There we go. That's doing better. And now if we run the attack, and let's show advanced options. So we can change up our technology, right? So I don't need to run anything but the MySQL attack because we know that's what we have. I'm going to run just PHP, and I'm going to run just the Apache stuff because that's all I have. Hey, Lasso. How you doing? Oh yeah, how's that going? Tenable CTF, very exciting. I've been so busy with work, I totally forgot about that. That's out of how many? That sounds pretty good. That's cool. How are you liking Burp? I did set up an account here. I guess I didn't really. Nice. Decrypting with Python. Always a good time. Looks like we're getting a lot of 302s here. I'm gonna... Okay, so we did find some vulnerabilities, but... Yeah. So, like, here's my quick take on Burp. It is an unbelievably powerful tool, and the stuff that you can do with it is really, truly incredible, especially stuff like Burp Collaborator, all the stuff that you pay for, right, is really amazing. But the user interface was designed by a psychopath. There's like no part of that user interface that makes any sense as to where things are located or how you navigate from one place to the next. Where's my HUD? I guess I don't have the ZAP HUD right now. There it is. There it freaking is. Okay, generate and analyze tokens. Find a request that contains the token you want to generate. Okay. This is driving me crazy. Look on the Sites tab on the bottom tabs. Generate tokens. Yes. No, I don't want to actually do that. Okay. But why can't I? All right, so our active scan is finding some stuff, but it's not finding nearly as much as I'd want it to find. Let's look at our users. Let's make sure that the stuff is correct. It should be. And so I'm having the same problem actually with the authentication, right? That the CSRF token isn't getting updated. It's a real problem. So interestingly, if I do an active, so if I like log in here, right? So I'm logged in. Oh, wait, because the security level is set to impossible. Maybe that's why I'm not finding anything. Yeah. Let's try the scan again. So we'll do PHP, Linux, and Apache. Go. Oh wait, did I set up the server user? I guess I didn't, but also I shouldn't have to, because my current tokens should be good. And if we look at alerts, let's see what we're finding. Application error, yeah, nothing too exciting here. I mean, it's DVWA, we should be able to hit something. See, I'm seeing a lot of 301s, which means I don't think I'm actually authenticated. Sure will be annoyed by the scanner if both wildcarded. Okay. Still seeing a lot of 300s, which means I mean, the thing with Zap is that it's not gonna, unless you're really careful with what you're targeting, it's not gonna, you know, do stuff that makes a lot of sense. So for example, it's like fuzzing all the images, which who cares, right? It's not really what we care about. And this is kind of the thing with web application vulnerability assessments is that, you know, you can throw a big attack at it, but if you really don't know what you're doing, you're not gonna find anything. Whereas, you know, watch this. If I go and do, let's just do like DOM-based XXS, right? I think this will work. So it's like English image source equals X or equals 1. Okay, so we did something. Let's see how we're breaking this, just to see how we want it to go. Oh, yeah. There we go. Getting closer. Let's see what this image looks like. Cross-site scripting confirmed. Now, did Zap find it? It did not. Right? So sometimes you just got to know what you're looking for. And this was, yeah, this was tracked by the proxy. So if we look at our history here, it should be in here. Yeah. So interesting. Yeah. So, all right, I think we're gonna call it for today. We've done some pretty cool stuff. We've looked at, Greenbone for vulnerability management. We played with Nuclei a little bit to see how that works. Lots to learn though, and I think we're going to continue with some of this next week, where we try to get this going. We try to get Nuclei templating working, and see what other tools are out there for doing automated vulnerability assessments for our assets. And we also talked about setting up virtual machines. So if you're coming in late or you haven't seen as much of this as you want, it's going to be on Twitch for a couple of days, but it's also recorded on YouTube. So you can check me out there as well. So thanks everyone for hanging out. Before we get out of here, just going to give a quick plug. If you like what we're doing and you want to contribute back to some folks who need some help, I highly encourage you to check out Human IT. They are a nonprofit here in the United States providing internet connections and computing devices to families in need. If you have some extra money that you can donate, then they will gladly accept your donation. Also, if you have lightly used computing devices, then you can donate them as well. You can check them out at human-i-t.org. And that's it until next time. Happy hacking, everybody, and I'll see you later this week.